Hi guys, this is O-Level Chemistry, paper 12, November 2017, question 1. A mixture of sand and sodium chloride can be separated in 3 steps. Step 1 is to add water to the mixture. The diagram shows steps 2 and step 3. Where is pure sodium chloride collected? So in the step 2, we have the mixture being filtered and the sand will be retained on the filter paper while aqueous sodium chloride will be collected in the beaker. And in step 3, we are evaporating the water from the solution, leaving behind solid NaCl. And the question has asked us, where is pure sodium chloride collected? It is collected in the evaporating dish. Therefore, the correct option for this question is option D. Question 2. The results of two tests on solution X are shown. Reagent added is sodium hydroxide. Observation on adding a few drops of the reagent is we get a white precipitate, and observation on adding an excess of the reagent, the precipitate dissolves. So our solution X might contain either Al3 positive ions or Zn2 positive ions because both of them give the exact same result with sodium hydroxide. And next, we add aqueous ammonia. A white precipitate is observed on adding a few drops of reagent and the precipitate remains. So here we can differentiate between aluminum and zinc ions because aluminum ions will not dissolve in excess of ammonia, whereas zinc ions will dissolve in excess of ammonia, giving a colorless solution. So these two tests confirm the presence of Al3 positive ions. Which ion is present in solution X? Al3 positive, making option A the correct option for this question. Question 3. Which diagram shows the arrangement of particles inside a balloon containing a mixture of the gases nitrogen and oxygen? So nitrogen atom is represented by a black dot and oxygen atom is represented by a clear dot. So nitrogen is a diatomic gas and oxygen is also a diatomic gas. So nitrogen should be represented like this with two atoms together, and oxygen should be represented like this with two atoms together. So in A, we've got atoms of nitrogen and oxygen, not molecules. So A is incorrect. In B, we've got molecules of nitrogen and oxygen, but they are held separately in different portions of the balloon. So that is not possible. In C, we've got the molecules of nitrogen and oxygen mixed together. This is the real situation. And in D, we have got one atom of oxygen bonded to one atom of nitrogen, showing that nitrogen monoxide has formed. That is not possible inside a balloon under the conditions used. So the correct option for this question is option C. Question 4. A student follows the rate of the reaction between marble chips, calcium carbonate, and dilute HCl. Which diagram shows apparatus that is suitable for this experiment? So one shows hydrochloric acid and marble chips reacting together and the CO2 gas collected over water inside a measuring cylinder. Two shows hydrochloric acid and marble chips reacting with the CO2 being produced lost. So we can measure the loss in mass of the gas. 3 shows hydrochloric acid in a burette reacting with marble chips in a conical flask. There is no measurement of mass or collection of gas to see the volume. So there is nothing being measured here. So this will not be suitable to follow the rate of reaction. And in 4, we've got a burette, a marble chips, but a gas syringe as well. So volume of gas will be measured and the rate of collection of gas can also be taken. So 1, 2, and 4 has the apparatus that we can use to follow the rate. 3 is not an experimental setup to follow the rate of reaction. So 1, 2, and 4 being correct makes option D the correct option for this question. Question 5. A chemist wishes to separate the and identify a mixture of substances using paper chromatography. The diagram shows the apparatus used. The solvent is water. The solvent front is allowed to reach the top of the paper before the chemist removes the paper from the solvent. Which problem does this cause? This causes a spot nearest the bottom of the paper to catch up with the spot above it? No, not at all. This makes it impossible to calculate RF values. Yes, because then we won't have a denominator value because RF is equal to solute front upon solvent front. If the solvent is made to reach the end of the paper, so we don't know whether the solvent could have gone even above it before the paper was taken out from the water. So this makes it impossible to calculate the RF values. Yes. This makes it impossible to use a locating agent. No, a locating agent can still be used. This results in a safety hazard caused by solvent fumes. Which solvent? It's water. No. So the correct option for this question is option B. Question 6. Which particle contains the same number of both neutrons and electrons? Okay, so in calcium, we've got 20 protons. We've got 40 minus 20 giving us 20 neutrons. And we have got 20 minus 2 equals 18 electrons. So the number of neutrons and electrons are different. In B, we've got 12 protons. We've got 24 minus 12 equals 12 neutrons. And we've got 12 minus 2 equals 10 electrons. So again, electrons and neutrons are different in B. C, we've got 9 protons. We've got 19 minus 9 equals 10 neutrons. And we've got 9 plus 1 equals 10 electrons. So here we have equal number of electrons and neutrons. And in the last one, we have got 16 protons. We've got 32 minus 16 equals 16 neutrons. And we've got 16 plus 2 equals 18 electrons. So here the number of neutrons and electrons is not the same. So this makes option C the correct option for this question. Question 7. Which statement is correct for all metals? They are hard and brittle. No, they are malleable. They are not brittle. They are hard and malleable. They are made up of a lattice of positive and negative ions. No, a lattice of positive ions surrounded by a sea of delocalized electrons. They conduct electricity by movement of electrons. Yes. Because electrons are free to move, metals can conduct electricity. They conduct electricity by movement of ions? No, by movement of electrons. So the correct option for this question is option C. Question 8. X represents the element of atomic number 8 and Y represents the element of atomic number 19. The two elements react together to form a compound. Which row is correct for the compound formed? So oxygen is the element with an atomic number of 8 and fluorine is the element. No, this is 19. Fluorine has an atomic number of 9. So the element with the atomic number of 19 is potassium. Potassium has an atomic number of 19. So when potassium and oxygen will form a bond, potassium forms a K positive ion and oxide forms a 2 negative ion. So the compound form would be K2O. And here Y represents potassium and X represents oxygen. So this would become Y2O. So option A and option B has Y2X present. C and D get eliminated. And this is an ionic bond, not a covalent bond. So option A gets eliminated. Therefore, the correct option for this question is option B. Question 9. The empirical formula of a liquid compound is C2H4O. To find the empirical formula, it is necessary to know the density of the compound. No. The percentage composition by mass of the compound. Yes, because in order to find the empirical formula, we divide the percentage by mass by the mass of the element, the air of the element. That is the first step. So percentage composition must be known. The relative molecular mass of the compound. If we need to find the molecular formula, then the relative molecular mass needs to be known. Otherwise, we can still find the empirical formula without knowing the relative molecular mass. The volume occupied by 1 mole of the compound is not required in finding the empirical formula. So this makes option B the correct option for this question. Question 10. 25 grams of hydrated copper 2 sulfate crystals are heated to produce anhydrous copper 2 sulfate and water vapor. What is the mass of anhydrous copper 2 sulfate formed? So, if we have copper 2 sulfate that is hydrated, so the mass of this copper 2 sulfate hydrated would be 160 plus 18 into 5. That would be 90, giving us a total mass of 250 grams. So 250 grams of hydrated copper to sulfate produces 160 grams of copper sulfate anhydrous. So we are given 25 grams of hydrated copper to sulfate. So 25 grams will produce how much of anhydrous copper to sulfate? The equation would become 25 divided by 250 multiplied by 160, giving us a mass of 16.0 grams. And this calculation shows that option B is the correct option for this question.